So welcome to my session. This session will be about SQL Server, mainly. It will also be a bit about SharePoint, but mainly about SQL Server. It will be fairly technical. We are going to cover some best practices in setting up SQL Server, in keeping it running, in doing little tweaks on, so you can have a very performant SQL Server to support your SharePoint installation. A little bit about me. I'm Thomas Vochten. I'm a SharePoint consultant based out of Belgium. You might notice my funny accent. So, okay. You can reach me via Twitter. That's most of the time the best way to reach me. I have a blog. I can be reached by email. What I do for a living is I do SharePoint consultancy. I'm an infrastructure guy. So SQL Server setting up, administration, planning, capacity management, etc. That's my thing. And I also do a lot of SharePoint, of course, and SQL Server. All right, we've got a lot to cover today. What are we going to talk about? I'm going to introduce SharePoint and SQL Server, how they fit together. That's, well, very important, of course. We're going to discuss a little bit some SQL Server fundamentals, things you have to know before you can set up SQL Server. How do you prepare your platform? That means how do you configure Windows and the disks, and what do you need to know? We are going to I'm going to show you how you can do a more deliberate installation of SQL Server, because many people just next finish their way through SQL Server, and it will work, kinda. It's a good product. It will keep on running for ages, but there are some little things you have to know before embarking on a setup operation. Then we have some real-world configuration tips fitted to SharePoint, so very specific tweaks you can make for SQL Server that apply only to SharePoint that you have to know. I'm going to give you some operational guidance on how you keep it running, how you can do consistency checks and backups, and why they are important. And last but not least, I'm going to show you some useful tools and resources and scripts I use every day to assess the health of a SQL Server. Okay, I've got a confession to make. I'm not a professionally trained DBA. And that's something I see many times in the SharePoint world. Many SQL servers in the SharePoint world are managed by people who do not consider themselves to be a professional DBA because, well, they manage SharePoint, so they have to manage SQL Server too. And that's, well, that's a bit of a problem. But I'm in the same boat, so. And we even have, we even have a name. We are involuntary DBAs. And an involuntary DBA is, well, someone who is made to assume a DBA role or take on DBA responsibilities, usually against their will. It's a bit negative, but well, it used to be called accidental DBA, but many people thought it involved DBAs that had accidents, so they changed the term. It's involuntary DBA right now. The term was coined by Paul Randall, one of the main gurus in the SQL Server world. He was on the product team of SQL Server. He has his own consultancy company now, but well, a lot of information on this presentation is coming from him and some of his colleagues. Okay, SharePoint cannot live without SQL Server, so it is important to know what the relationship is and what you. We do a quick walk around the SQL Server and SharePoint ecosystem. Okay, what is the importance for SQL Server to SharePoint? Well, it's very important. The major one being a performance impact. I've never had a customer that complained that SharePoint was too fast. And mainly, well, SQL Server is one of the main contributing factors to SharePoint performance, being it perceived performance or real performance. Almost everything is stored in SQL Server. I heard many statistics this week around how much data is stored in SQL Server. Well, it ranged from about 70 to 90%. Well, I don't know, but it's a lot. So. And of course, SQL Server is the main supporting technology for your high availability and your disaster recovery strategies. If you want to do high availability, you have mirroring or clustering or high availability groups. That's something new in SQL Server 2012. And it can also support disaster recovery, log shipping, well, backup restore even. So very important. And even when you use remote blob storage, you still need SQL Server. Now in SharePoint 2013, they made many optimizations to the way SharePoint is connected to SQL Server. Many schema optimizations. That means the inner workings of the database tables of SharePoint in SQL Server. They changed, they removed tables that they didn't need, legacy stuff. They added indexes, they removed indexes, they did all kinds of changes that had a big performance impact. So reduced I/O operations. For example, opening a document or viewing a document library takes a lot less database calls in SharePoint 2013 than it did before. Another contributing factor was distributed cache, but it's not a SQL Server feature, it's a SharePoint feature, but resulting in much less calls to SQL Server from SharePoint. For example, your social feed is not retrieved from database anymore, well, not constantly, but retrieved from distributed cache in memory on the web servers. And last but not least, shredded storage. And that's something new. Shredded storage is more an evolution of something we have already had in SharePoint 2010. In SharePoint 2010, they introduced the concept based on Cobalt. Cobalt was some kind of feature in SharePoint 2010, where the traffic between the client and the web server was optimized. That means if you opened a document, a newer Office document in SharePoint 2010 from your client, and you saved something, only the change blocks or the changes were sent to a SharePoint server. But on the SharePoint server itself, SharePoint still had to retrieve the full document from SQL Server, merge the changes, and send the complete document back to SQL Server. And that's shredded storage. That's what they fixed now. So only the change blocks are sent back to SQL Server, starting from SharePoint 2013. So every document is split up in different chunks of data, little chunks, and they store them in a table. And when you have to retrieve a document and change something, they only save the saved chunk back to SQL Server. So you have less storage that you need and less I/O calls to SQL Server. So only the changed blobs will be sent back to SQL Server, resulting in reduced I/O and storage needs. Now, it works even with versioning. So if you store a new version, only the changes will be sent to SQL Server. Unfortunately, when upgrading from SharePoint 2010, well, your database is migrated as such, but only when you make the first change, the document is shredded. So all the documents that are migrated from SharePoint 2010 still remain in their complete form in SQL Server. Only when you make the first change, shredding is applied. As you all know, SharePoint has a lot of databases. I did not do an exact count, but I think it will be about when you install every service by default and you install a portal application or My Sites application, you have something like 24, 25 databases in total. That freaks DBAs out. When you just install an application and you run the farm configuration wizard, which you shouldn't do, and then you have 25 databases. And all of these databases have different needs from an I/O perspective, from a capacity perspective. There's a very good technical article, a very long technical article that details all you have to know about all of these different databases. So for example, the configuration database is more read-intensive. The logging database is very write-intensive. The logs are read and write-intensive, so they all have special needs that you have to provide for. So the limits and boundaries, you've probably heard this many times before. 200 gigabytes is still considered a sweet spot for a content database. In the past, the advice was to have 100 gigabytes, then 200 gigabytes. Well, for general usage, 200 gigabytes is still okay. You can do much, well, you can do what you want with 200 gigabytes. You can go to 4 terabytes in a content database if you really know what you're doing. That means if you have the operational procedures, if you have the hardware and the storage to make backups and restores very fast, for example, with snapshots, etc., then you can go to 4 terabytes. And you can even go beyond 4 terabytes if you use Document Center and if you have a lot of documents that don't change very often, for example. It's all detailed in TechNet, but I don't have time to go over everything, of course. But personally, I think 200 gigabytes is still what you should aim for in a content database. So you can have 500 content databases per farm. Performance is okay until you reach 500. After 500, well, adding site collections, etc., will become slower and slower and slower. So you can have 60 million items in one content database, so items of whatever kind. And you can have 10,000 site collections in a content database. But Microsoft advises you to, that's a supported limit, but Microsoft advises you to only use 5,000 site collections in one content database. And even of those 5,000, 2,500 of them, maximum 2,500 of them can be general site collections. The rest has to be My Sites. So it's a bit. Okay, what kind of version of SQL Server can you use with SharePoint 2012, that is? SQL Server 2012, 64-bit, of course. I don't think anyone uses, I hope not, uses 32-bit SQL servers anymore, but, well, that's what you need. Same goes for SQL Server 2008 or 2. You need Service Pack 1 also to be able to support SharePoint 2012. The editions that are supported, I said standard enterprise and data center. Well, that's all fine, but well, I lied a bit because if you do a complete installation, you know, the option in the configuration wizard you don't have to check, then you end up with an Express edition, but we don't care about Express. You never should choose this option. Always go for standard enterprise of data center. Each of these SQL Server versions come with different capabilities, of course, and with a different license. And recently, for SQL Server 2012, they changed the licensing so that you now have to pay per core and not per CPU socket. So it may be cheaper to buy servers with less cores and, than you had before. Basically, this rules out AMD in most of the servers we buy right now, because AMD has a lot of cores, very cool, in the past. But now, well, you're basically, if you want to have a good cost balance, you're stuck with Intel, I think. That's my opinion. Now, SharePoint is a bit controversial among DBAs. I wouldn't really say it makes them cry, but, well, they don't like it very much. Well, why is that? There are different reasons. SharePoint likes to do things the SharePoint way. That means the internal workings of the SharePoint databases are very unconventional for DBAs. We use GUIDs all the time, not only in the table names, well, you can avoid this, of course, but also as primary keys in your tables. They are very big. It's not very efficient, but, well, we have to live with it. It's a legacy from the earlier SharePoint versions. So a lot of GUIDs. Well, there are a lot of things you can't do with SharePoint databases, or that DBAs are used to. And, well, the support policy, well, in the past you couldn't even look at a SharePoint database and because you became unsupported, but now you can do some little things that are supported. Now, these GUIDs, well, it's very important to get rid of them because, well, it's not very clean. You have to have a database naming strategy. It's not nice to have 45 databases with all GUIDs in them, and you can't do anything without them. With them, sorry. So there is a metaphor that everyone uses. You know the gray wizard and the white wizard from a certain film. There is an analogy in SharePoint. The gray wizard is good and the white wizard is bad. Same goes for SharePoint. This one is the good wizard, and that's the bad wizard. The white one is the bad one. So never run the farm configuration wizard on the right, because you will end up with all kinds of databases with GUIDs in them. There are a lot of other problems with this wizard, like, for example, by default it creates a web application with a server name, and if you have two servers, well, what do you have to do? So that's a bit problematic. Now, I must say, even if you use this wizard, you still end up with one GUID in the administration content database. So how can we avoid this GUID altogether? Is use PowerShell, of course. I think by now everyone knows we have to use PowerShell. Well, it started in 2010, and, well, it didn't go away. So new SP configuration database, if you issue that command, you can choose a configuration database name and an administration content database name without a GUID. And that's how it should be done. A very nice project if you want to automate SharePoint installations is AutoSP installer. It's created by a guy, Brian Lallenset, and it's a very nice project. It's based on an XML file that you put all your parameters in, and then you launch PowerShell, and your farm is created, even across multiple servers if you want to. So definitely have checked it out, AutoSP installer. It's immensely powerful. Okay. We're going over some SQL Server fundamentals right now, things you have to know to understand what I'm going to talk about later on in this presentation. SQL Server uses a concept called pages. And that's a representation of a page. And a page is basically an 8K block that SQL Server uses to write its data in, well, more or less. But it doesn't write pages directly to the disk. It writes 64K blocks of 64K to the disk. Those are 8 blocks, or 8 pages of 8K, 64K. And that's used as the basic unit of storage. So whenever SQL Server writes or reads data from disk, it does this in 64K chunks. Remember that, because it's very, very important. Now, there are two kind of files involved in SQL Server world to store data, and log files are MDF files and LDF files. Well, in fact, there is a third called the NDF file, but, well, we're going to talk about that later. So the data is in the MDF files and the log files in the LDF files. Or the log records, I must say. And then there's something like indexes. Well, indexes is also very important for performance. You can compare an index to an index in a book. So you have a long list of references. Most of the time they are sorted from A to Z, for example. So you can quickly find information in your book. And well, the problem is that with indexes is that sometimes whenever something changes, you have to change the index. You have to add records or you have to delete stuff from the index. And that can be problematic for performance, as what I'm going to show you later on. So index is also very important for performance. Then there are some SQL Server databases that you have to know about. We have system databases and user databases. User databases are your SharePoint databases, the one that you create yourself or that SharePoint creates. Now, the system databases, the master, the model, MSDB, and the TemDB. Now, the master DB is, well, you can compare this to your SharePoint configuration database. It contains all settings, it contains the name of the databases, everything you need to know, everything you need, to keep your SQL Server running. That's the master database. Very important, of course. Without master database, you don't have a SQL Server. Then the model database is what it is what it says, I mean. So the model database is used to create new databases. It's a template. So changes you make to the model database are reflected when you create a new database. So if you create a new database, you have the same settings as the model database. Unfortunately, SharePoint doesn't really use the model database. So it likes to do things the SharePoint way, like I said. MSDB, that's a database that contains all the maintenance jobs, all the agents, all the alerts, everything around operations. That's in the MSDB database. And then we have TemDB. And TemDB is, well, perhaps not the most important database, but a very important database. Don't let the name fool you. TemDB is very, very important for SharePoint. Because everything you do in SharePoint, well, more or less everything, is first happening in TemDB. For example, sorting views. That's something that happens in TemDB. Doing searches, TemDB is involved. So you have to give it proper care. That means put it on the fastest disks that you can afford. It's more important than the SharePoint databases. It's more important than your content databases, service application databases. Absolutely the most important database as performance is concerned, TemDB. What is special about TemDB is that it grows over time. Or it can grow over time. So as you do operations in SharePoint, TemDB is used, and when you use it a lot, well, the database grows. It grows and grows and grows and grows and grows and grows until a certain size, so it grows organically, more or less. But when you restart SQL Server, TemDB is reverted back to its original size, which is, I don't know by heart, but I think something like 25 megabytes. And then when you start working with SharePoint again, the database grows and grows and grows and grows and grows and grows again. So it's a good practice to let it grow and then fix the size of the database. I will show you later on that you can configure a database size, and that's something you should do for TemDB also. So initial sizing is very important. I will show you that in a demo. Another thing you can do to TemDB to speed it up is create additional data files. We saw the MDF files. You can create multiple MDF files. Most of the time they're NDF files, but well, it doesn't matter. It's the same kind of data file. And you configure the same amount of data files as you have CPU cores. Now, I wouldn't go so far to say that if you have 32 CPU cores that you have to create 32 TemDB data files. That's perhaps a bit, well, it's overkill. But, well, for example, creating 4 or 8 TemDB data files would be okay. So as SQL Server is working with TemDB, it can use its different cores to write or read data from these different data files. It's much faster than just having one. Like I said, you have to put it on a dedicated drive, and you have to tune the auto-growth settings. By default, SharePoint will grow your databases, well, something like 1 megabyte at a time. also for the content databases. So if you add a document, the database has to grow. You add another document, the database has to grow and grow and grow and grow and grow. This growing takes time. So it's best to configure TempDB, well, for example, if your TempDB is 20 gigabytes, to configure it to grow with 1 gigabyte at a time. It will take some time, but you have space enough for the next operations. Okay. The next one is recovery models. Now there is one article that you definitely need to read. It's here for reference, of course, if you get the slides afterwards. It's an article by the same Paul Randall, Understanding Logging and Recovery. If you read that article, you're cool. It's essential reading. It will tell you all about how SQL Server manages data and how it does recovery, how it's working with the log files. Unfortunately, I don't have time to explain everything, but the two important things are here. You have two recovery models, simple recovery model and full recovery model. Now, a recovery model is dealing with the way SQL Server handles the log files. By default, if a database is in simple recovery model, if it changes data is first changed in memory, then changed in the log files, and then it's put in the database file. If the simple recovery model is active, then SQL Server will write data to the log files, write it to the data file, and after a few minutes, the log file will be marked to be overwritten. That means the log file is being reused all the time. It's being reused and reused and reused. That's a simple recovery model. When do you need to have the simple recovery model? If you're okay to go back to the last full backup. That means if you have a problem with your database, you restore the last full backup and you're up and running. If the last full backup is from yesterday evening, well, you have potentially data loss of 24 hours maximum. That's simple recovery mode. Now, if you want to have more granularity in your restore, you can use the full recovery model. In the full recovery model, SharePoint still makes changes to the log files and writes them to the database file, but it doesn't mark the log file to be reused again. So it just adds log records to the log file. And so if you have a problem, you can restore the latest full backup that you have, and then SQL Server will go looking, or you can configure a certain point in time, will go looking, okay, here my backup was created, I need these log files to replay all the transactions, and I can have my data back, the data from, well, 2 minutes ago, for example. That's a full recovery model. So when do you choose between how do you choose between the two? It depends on your recovery target. If you're okay with the last full backup, go with simple recovery model, and if you want up to the minute restore, as they call it, go with the full recovery model. Now, there are other situations where you have to choose the full recovery model. For example, if you want to use high availability techniques like mirroring or log shipping, you need the full recovery model because you have to keep all the transactions. Now, the full recovery model sounds fine, but there is one problem with it. A problem that many people encounter, that is, in the full recovery model, the log file grows. And it grows, and it grows, and it grows, and it grows, and it grows forever if you don't do anything about it. I've seen many cases of content databases in SharePoint that are 5 megabytes, or 5 gigabytes, I must say, and log files of, 150 gigabytes, for example. It's very common. And it's because people don't know how to handle the full recovery model. Now I'm going to demonstrate how this works and what you can do about it. Okay, whoops. This is my SQL Server. Now, what we are going to do is we are going to create a database. It's called SP Evo Big Data Content. It's a content database in SharePoint, let's say. We are going to create a database. Then we are going to create a table in this database. Doesn't really matter, but we have to do this. And then we are going to change the recovery model of this database to full recovery mode. You can do this in the user interface also, of course. So we put it in the full recovery mode. Now, okay, let's refresh. So I have my big data content database here. What we are now going to do is we are going to add stuff to this database. I'm not a programmer, but while 1 is 1 means, well, we're just going to continue adding records to this table. Okay. We're now going to add data. Okay. Now let's see how that looks. This is performance monitor. I'm going to quickly add some counters so I can show you visually what happens. Where is it? Databases. And I'm going to add 3 counters: log file size, log file used size, and the percentage of the log that is being used. And I'm going to do this for my big data content database. Okay, I'll just have to change the scale here. Okay, now what do we see here? The blue line is the percentage of the log file that is being used. So around 60–70% of the log file is being used. So all the transactions are going to the log file. And the red line is the actual size of my log file. And the green one is the percentage that is being used here. But as I said before, when your database is in the full recovery model, the log file keeps on growing. But it doesn't go at all. You see, it stays the same. I'm adding records, and nothing changes. Well, that's also a second problem with the full recovery model. Oops. Is that, for example, you go into production with your SharePoint databases. You have a big content database. You put it in production. It's in the full recovery model. You start using it, okay? And then comes in a very clever administrator, and he says, oh my God, we have a new database, and we're not backing it up. I have to take a full backup now because, well, we're live. We have to take backups. So the database administrator goes to SQL Server, and he takes a backup, a full backup. And we're going to take a full backup every night. Okay, we take a full backup. Let's see what happens. Watch the blue line. That's strange. The percentage of our log file that has been used is going up. And when it reaches 100%, the log file grows. So that's very particular about the full recovery model. The full recovery model goes into effect the first time you take a full backup, and then misery starts. If you say, well, okay, I just take another full backup tomorrow or this evening, and I will be okay. Well, that's not the case. You see, the log file keeps growing, growing, growing. Well, let's take another full backup. What? Full backup? Now, surely the growing will stop. Oh, no, it doesn't. Keeps on growing. Well, let's take another one. We have to keep this log file under control. Up, full backup. Now it will be okay. No, it doesn't. Oh my God. Okay. So you see the problem. You can take full backups as long and as much as you want. The log file will not stop growing. What you have to do is create a log backup. And that's essential. If you go for the full recovery mode, you have to create log backups. So let's now create a log backup. And then you see the blue line goes down. Unfortunately, the size of the log file, well, stays the same. That's the physical size of the file on the disk. But the usage internally, it's being reused now, see? Because we took a log backup. So what you have to do is take regular log backups. Let's take one again. Usage goes down. So every time you take a log backup, it's like that. So whenever you encounter a log file that is growing and you don't know what happens, there is another command that you can do to see, can execute to see what is happening and why the log file is not being truncated. Well, well, truncated is a bad word because it's not being truncated at all. It's being marked for overwrite. Well, it's very, it looks very complicated, but the thing we are looking for is this one, log reuse weight description. Every database has a property called log reuse weight description that you can query to see, okay, why is the log growing? So if you have a runaway log file, like they say, you execute this procedure and you see, oh, well, it's nothing. Let's wait some bit. Well, I have to wait until this blue line reaches 100%. So if 100% of the log is being used, the log file will grow and we can see why it grows. So without doubt, everyone here in the room has had experience with this situation, I suppose. That's one of the classical examples. And I must say, well, I had it also. So it's, well, okay. Well, we're not going to wait for the blue line to reach 100%, but when it reaches 100%, this one will say log backup. So if you query this value, you will see that the database is waiting for log backup, and that's why it's growing. Still growing? Well, okay, we'll just wait until it reaches 100%.
Which is creating log file backups will not help while recovering.
Sorry?
If you recover, just having old full backup and long times of log file backups, you will have to replay them all in.
Yes, yes, yeah. Yeah. So it reached 100%, and the log file is growing again. Let's see. If we execute it, it's log backup. So we need a log backup to keep the log file under control. I'm going to stop the procedure, because otherwise my PC will stop working. All right. Okay, so why does the log file grow forever? Because you need log backups. That's very important to understand, and one of the main takeaways of this presentation, I think. Okay, now we're going to prepare a Windows server to host a SQL Server instance. And SQL Server is all about memory, disk I/O, and CPU, and I even think in that order. Memory is the most important factor for SQL Server performance. If you have a SQL Server box, put as much memory as you can afford into the box. Very important, because everything is first done in memory and then transferred to disk. And disk I/O is a second important factor. CPU is also important, but well, much less than memory and I/O. Then, something else, what is also a little bit controversial, is to dedicate a separate SQL instance to SharePoint. SQL instance is an installation of SQL Server on a server, and you can have multiple SQL instances. So you can have multiple running SQL servers on the same machine. And the best practice is to have a SQL Server installation or a SQL Server instance for your SharePoint server. Why? Because we are going to change some settings on this instance level that is not compatible with other applications, perhaps. And then, well, even a bigger debate is virtualizing SQL Server. I've done it. You can do it. It's no problem. But you really have to know what you are doing. Some people say that even if you even think about virtualizing SQL Server, you don't care about performance. But, well, depends on what you want, of course. If you virtualize SQL Server, well, think about memory reservation, dynamic memory in Hyper-V, etc. It's not good for performance. Big debate. So you have to plan our disks. Come on. Is my PowerPoint dead? No. Okay. if you go to your storage guys and ask for disk for SQL Server, there is a minimum, in my opinion, a minimum of 4 different disks that you have to ask for. One for TemDB, one for all the logs, one for search, and one for other databases. And other databases are the configuration database, your content databases, most of the service application databases. Those are other databases. And the order is important. TemDB and logs have to be on the fastest disk you can afford. Typically, that will be RAID 10. Very expensive. You need a lot of disks. Very important for performance. And then search, well, also very important. Other databases, content databases, well, they don't need RAID 10. You can get away with RAID 5, perhaps. So, because TemDB and logs are very write-intensive, and RAID 10 is optimized to be for writes, and RAID 5 is more optimized for reads, or is better suited to have reads. And it's also less expensive because you need less disks. So go for these 4 disks when you go to your SQL to your storage guys. And also for the content databases here, consider having multiple database files. Now, when preparing our disks, there is another issue that you have to be aware of. Well, at least 2 issues: partition alignment and the allocation unit size. Before Windows Server 2008, partitions were not aligned to the beginning of the disk in an optimal way. That means you have the disk, your physical disk, and then there is a partition within that disk, and it starts at a certain offset. And before Windows Server 2008, it was 32K, because we had to save space. 32K. So your partition started at 32K after the disk. But that meant when you had a SAN or some kind of RAID configuration underneath, well, that typically does not align with 32K. So the sectors and everything you have in your RAID configuration doesn't align. And that leads to, for every read and write, the disk had to go to 2 different disk sectors. So you have 50% loss in performance. And the same goes for the more logical layer of NTFS, the allocation unit size, or the cluster size as they call it sometimes. For SQL Server files, you have to set this to, well, it's best that you set this to 64K. Remember the 64K extent that I talked about in the beginning? SQL Server reads and writes data in 64K blocks. That's why we need this. For example, if you write 64K block to the disk, if you're not using 64K as a cluster size, NTFS has to go read 2 clusters. So you have to have 64K. And if you configure this correctly, you can gain up to 50% I/O improvement. So if you inherit an old disk that was formatted once by a Windows Server 2003, or even if you inherit any disk or get any disk, always check these 2 parameters to see if they are correctly configured. Now, how can you create a disk with the right settings? You can do this in disk part. You can also do it in the user interface. Well, we really select a disk, we create a partition, and we align it at 1 megabyte. And then when we format it in NTFS, we gave it a cluster size of 64K. That's how it should be done. And when you receive a disk, it's also very important to check performance and to test them. There are 2 tools that I use. First one is SQL I/O. Very intensive tool. Be very careful. SQL I/O, when you run it, you can give it a sort of number of parameters. But it's very easy to take your SAN down if you use SQL I/O, and I have experience with that. So be very careful. Talk to your SAN guys before you will be running SQL I/O. Do it in the weekend or during, well, off-peak hours, or be careful with the parameters. Another tool which is much less intensive is Crystal Disk Mark. Gives you a nice impression of what the disk performance is from an I/O perspective. Crystal Disk Mark, you can also run it on your PC to assess the performance of your SSD drive, for example. Okay, I'm going to quickly show you about the disk size and allocation units. Okay, So if we go to Disk Manager, who loves Windows Server 2012 and the Start menu? Well, no one? I'm not going to create my, my partition with disk part. You can just do it here. When you create it in Windows Server 2012, the disk alignment is OK. Just create a disk, assign it a drive letter, and then this is the allocation unit size that I talked about. See, standard is default, but for SQL Server data files and log files, you can set it to 64K, the biggest one possible. And then format. The default is 4, I think. I think the default is 4K. Is that right? Yeah. OK. Now, with disk part, you can check the partition alignment, but you can't check the allocation unit size. Now, there's a very nice trick that you can do to check the allocation size of a disk that you get handed. For example, this is my C drive, which has been formatted with the default allocation size, and I created a text document, and it just contains 1. So almost nothing. It's a very small file. And we take the properties of a file on any disk. You've got these two here. Size, 1 byte. Size on disk, 4 kilobyte. So this disk was formatted with a 4 kilobyte allocation unit size, so it being the default. That's optimal for a drive with a lot of small files. So they don't take 64K for every simple text file. And then if you configure your SQL disk correctly, and you have the same file, you create the same file on this disk, you see it's 1 byte on disk, 1 byte is a file, but on disk is 64K. And if you see this, then it's formatted OK. Now, if the partition is not aligned correctly, or the allocation size is not aligned, is not OK, the only thing you can do is remove your disk, well, remove the partition it again, format it again, and then you're OK. But be sure to check this because, like I said, you can have at least 40 or 50% performance gain when you do so. Okay. Come on. Right. Next thing is about setting up SQL Server. Most important thing is only install the features you need. I can't count the number of times I encountered the SQL Server for SharePoint. I had reporting services, analysis services, integration services, whatever tools, Visual Studio, everything is included. Don't do this. If you only need the database tools, the database engine, I must say. So don't install everything. Always use a domain account as a service account. Don't use network service or local system or anything else. Use a domain user. It's also handy when you do backups, for example. Then you can write to a network drive, something you cannot do with network service. Don't lock out the other admins. They added a feature in SQL Server 2008 or 2. When you do the setup, by default, only the user that is setting up SQL Server has system administrator rights afterwards. You have to change this. You can configure the data and the log files right away. And you have to set the right collation settings. Collation is the way SQL Server stores files in the database. For example, special characters and uppercase, lowercase. It's best practice to configure your SQL instance with this collation setting. Now, how does that look? Don't use this feature, all features with defaults. No, always go for SQL Server installation, and then choose only the things you need. For SharePoint, basically, all you need is database engine. Well, this one is even not required, but well, the management tools come in handy when you want to administer your SQL Server. Don't install all the other things. Sometimes you will need to install full text and semantic extractions because some web parts use this for search manipulation. But basically, those two are what you need. So this is how you configure a domain user account. Pretty straightforward. And this is how you configure the right collation settings. By default, for my installation, it's Latin 1 general, and then you have to check these two. kana sensitive, that's for Japanese, and width sensitive. And then you end up with this nice string, and that's the correct one. All SharePoint databases are created with this collation setting. Also, if you ask your database administrators to pre-create your SQL Server databases, which you can do, normally SharePoint will create the content databases, but you can ask your DBA to create them for you. Be sure to ask them to use this collation setting because you cannot change it afterwards. And this is where you add the administrators. This is the button that's there by default. Add current user. Don't use this. Use this button, and add a group or, well, different people. So afterwards, if your account is deleted from Active Directory because you have another job, that people can still administer the server. There is a way around this, but, well, it's not pretty. OK, another important step is that you can align the disks that you have. I have different disks, TempDB, logs, search, and content, and you can specify them during setup. So the TempDB ends up on the right drive, and all the logs end up on the right drive also. By default, when SharePoint will create databases, they will all end up in this one, user database directory. Patching SQL Server is a bit different. The patching philosophy is a bit different than SharePoint. In SharePoint, we say go for the latest service pack, and if you really need it, install a cumulative update. In SQL Server, they more have the tendency to install the service pack and always the latest cumulative update. It's a different philosophy. The partition alignment and the allocation unit size was the first performance trick that has a big impact. This is the second one. And it's something that is, well, not widely known, even among DBAs. I give the same talk for DBAs to teach them about SharePoint Server and that they don't have to be afraid of it. And not a lot of people know this. It's a feature called instant file initialization. What happens when SQL Server or any file is created on the disk, NTFS or Windows will write zeros in the file first. And that takes time. So if you have a TempDB or a normal database and you let it grow, every time the database has to grow, it has to write zeros. And that's, well, for a content database of 100 megabyte, that can easily take, well, not seconds, but minutes to make it bigger. And during this operation, when you make it bigger, SQL Server will block all I/O to the file, so you cannot read or update, well, all writes to this database, so you cannot write anything to it. So that's something you have to change. Unfortunately, this is only true when you use a domain user account. So if you follow the best practice of using a domain user account, you're stuck with this, and you have to enable this manually. So how does that look? Let's see. I just want to quickly show you the difference in performance. I have a database here, SP-evo test content, and I'm going to change it. I'm going to grow the file until it reaches 1 gigabyte. And we are going to time how long it takes. It took 467 milliseconds. Now, with instant file initialization enabled, and you can do this in local security settings. I've got a blog post that details this. I will reference it at the end, so you don't have to write this down. In local policies, user rights assignment, there is a right called perform volume maintenance tasks. And by default, only administrators have this right. And when you give your SQL Server account this right, let's see what it was, SVC. That's my SQL Server's account. We add it. Then we have to restart SQL Server, unfortunately. We will see how long it takes to grow the file again. Come on. Let's grow it to, well, 2 gigabytes, same amount. I have to connect again because I restarted my SQL Server. Okay, Let's do it again. So we had 467 milliseconds. Oops. And now it's 24 milliseconds, you see? And I only grow with one gigabyte. So imagine how long it would take if you do this with, 10 gigabytes. Okay. So instance file initialization. And I see that I will be horribly running out of time. So okay, some configuration tips. You have to start the SQL Server agent. That's the tool that is responsible for doing all the jobs. You have to set up alerting to get notified when certain corruptions may occur. And don't forget to open Windows firewall port, because by default, it doesn't open a firewall port, and you're stuck there trying to figure out why your SharePoint server cannot connect to SQL Server. Open the port first. There are some very specific instance level settings we have to configure. Maximum memory. By default, SQL Server will consume all memory that it can take. It's very typical if you go to a SQL Server and you go open Task Manager, all memory is consumed. So it's a good practice to cap this off a bit so that you can still have your Windows OS running. You have to set the fill factor to 80. That's related to the indexes that I already talked about. You have to turn on, well, you don't have to, but it's a good practice to turn on backup compression. And last but not least, set maxed up to 1. Now, maxed up stands for maximum degree of parallelism. And it configures the way SQL Server is handling the way queries are executed. By default, SQL Server determines itself how many processes are used to run a query. But for SharePoint, it's a good practice or best practice to set this to 1. So only one CPU core will be used to execute a SQL Server query for SharePoint. For 2010, this was recommended. But for 2013, you have to do this. If you don't set maximum degree of parallelism and you run the configuration wizard or you do it in PowerShell, you will be greeted with this error. Maximum degree of parallelism is not set. So you have to set it first. If this account that you are running the PowerShell with has sufficient rights in SQL Server, it will change the SQL Server setting itself. But you have to do this. Okay, I more or less talked about all these things. I'll have to speed up. Then, how do you connect SharePoint to SQL? Typically, you have to use, you might use SQL aliases. Does anyone know what a SQL alias is? Most of you? Okay. So a SQL alias is some kind of extra layer on your Windows server that you can use to connect to SQL Server, and it's a very flexible way to change database connections afterwards. I'll show you what that is. This is my SharePoint server, I wanted to say. Come on. The problem is when you are using VMware and you're pressing Windows P to change the screen, it does this only in the virtual machine. That's not what I want. Okay, better. So my SharePoint server. When you go to system settings, I hope it works because I restarted my SQL server. You go manage servers in this farm. You see I have SP Core here. Now SP Core is not the name of my SQL server. That's a SQL alias. And you configure a SQL alias with a little tool with a very handy name, config without an I at the end. I don't know why. And then you get this screen to define an alias. Now this is the one I used to create my configuration database. SP Core, but it actually points to this SQL Server instance on DB05. That's the real SQL Server name. Now what you can do for example, is you can create multiple aliases. I created one, SP, well, that had to be SP search, and SP logging. So when I create the logging service application, I use this as the database server name, SP logging. But underneath is going to this other server. And if you want at one day to change this, because the logging database is very intensive, you just have to go to your web servers, press edit, and change the underlying database. And then SharePoint server won't know and will continue to keep working. Very handy. Yeah, I'm inside the VM again. Right. Some operational guidance. There are two things you have to require reading. This knowledge base article details what you can do and cannot do to a SharePoint database. For example, you cannot create indexes, you cannot modify tables, etc. That's this knowledge base article. And the second one is essential reading if you want to go maintaining your databases. It's this white paper. Database maintenance for SharePoint 2010 products is still okay for SharePoint 2013. I think more or less nothing has changed. If you downloaded this white paper before, I mean 2 or 3 years ago, be sure to download it again because the newest version is okay. The original version had all kinds of horrible advice in it. So be sure to download it again. It was revised by the same Paul Randall. So what you have to do, and I would say at least once a week, is do regular maintenance. For example, checking your database's integrity. Because a lot of things can go wrong. When SQL Server writes data to the disk, it's never sure that the disk actually did this. So there's a command, dbcc checkdb, that I would advise you to run every week. What you also can do is check index fragmentation, because as I said, you have the index in your book and you change something. Well, there are a lot of gaps, and that's not good for performance. And you have to learn about maintenance plans. Now, if you use a maintenance plan to configure the fill factor that I told you about, don't be, well, read very carefully, because I think Ben here had a very good blog article about the maintenance, using maintenance plans to use to change the fill factor. It's very strange. It's very strange behavior.
The article's never been updated. It's still wrong. So if you read
Yeah, I checked this morning. It's still wrong. Yeah, it's still wrong. So even the database maintenance white paper is wrong. Yeah.
Oh, really? Okay.
Yeah. So.
The guy at Microsoft described it as logical inversion.
Yeah.
He never updated it.
No. Okay, this visual representation of what happens if your indexes are changed, if you add or change data. So normally the indexes are aligned like this, and well, if you add or change data, it becomes fragmented. So the order in which SQL Server has to read the pages changes, and that's not good for performance. And there is a procedure that you can use to check how bad it is. Now, SharePoint itself does some maintenance too, with the health analyzer maintenance jobs, and it goes to rebuild some indexes automatically for you. But nevertheless, I would urge you to check manually if your indexes are still okay with the procedure on the last slide. Okay, and if your indexes are fragmented over 30% for content databases, you have to rebuild your index for performance. For search databases, that's something like 10%. And then watch out for the shrink. Also very common mistake. Data files grow and grow and grow and grow, and then you remove some portions of data. And in SQL Server, you can see that there is a large amount of free space. And then people tend to shrink database files. But if you do so, that causes massive fragmentation. So, and I'm talking, well, if you have the database before the shrink operation, it's, well, something like 1% fragmented. And when you shrink the database, it's 95% fragmented. So very bad for performance. If you really need to do it, well, be very careful. Don't shrink it, and don't leave any white space at the end of the file. Leave some free space so it can grow. And auto shrink is the root of all evil, because, well, yeah, that's an option that you can set in a database, that it shrinks automatically every night. It's horrible. Okay, I'm not going to show you CheckDB because it's just a command that says, okay, the database is checked. So some useful tools and resources. These are the tools I use at almost every SQL server I administer or I encounter. That's Ola Hallengren. It's a guy from, I think it's Sweden. And he has scripts for backup and consistency checks, which are very valuable. You definitely have to check that out. So it's basically installs a stored procedure that's much easier than the built-in database commands to back up a database or do consistency checks. And then to diagnose a SQL server, the main tools I use are these one. The Blitz scripts by Brent Ozar. It gives you a nice list of all very special things that are going on in your database instance. For example, if you didn't back up your databases the last few days, if you have databases in the full recovery model that don't have log backups, if there is something with your indexes, etc. So very valuable, Brent Ozar. Whenever I go to a customer to do a SQL Server assessment, I always use this tool first. Second one from Glenn Berry, diagnostic scripts. He has one for every version of SQL Server. Also very important, more hardware related, if you want to know something about processors or indexing. And then the PAL tool. PAL tool is a tool from Microsoft that you can use to gather performance metrics and then analyze them to see, okay, do you have a memory problem? Do you have a CPU problem? That's okay. I have 1 minute left, I think, so I will demo this Blitz script. Sorry, I had to speed up a bit. Come on. Fiddling with PowerPoint and then VMware is always fun. Okay, let's go to my SQL Server. I installed the Blitz script already. So when you install it, you just have to run a new query and say sp blitz. sp is not SharePoint. It's a stored procedure. That's by coincidence. And then you run it. And then after a few seconds, it will give you a large list of possible issues. I say possible issues because remember how I said that SharePoint likes to do things the SharePoint way? A lot of these things are complaints about SharePoint databases that don't do things in the recommended way. So for example, we'll say, okay, the last good check consistency check that you did is over 2 weeks old, for example. It will say that certain databases are not backed up. These are all complaints about SharePoint databases. File growth is set to 2% and not to a fixed amount. Typical things. You change the fill factor, but that's good because we use SharePoint. Maximum memory is set too high because I didn't configure it, etc., etc., etc. And all these databases have triggers because it's SharePoint. Well, it's very, very informative. I use it most of the time to see if if the customer takes backups. So. Full recovery mode without log backups. You see, these 3 databases are in full recovery mode and didn't have log backups yet. The Blitz script, my favorite tool. This presenter mode is killing me. Can I switch it off? Come on. Okay, and finally, I try to stuff a lot of information in 1 hour, but if you want to know everything about using SQL Server with SharePoint, definitely check this out. It's a 4-hour video series by Brian Alderman and Bill Baer. Brian is here this week, so he might still be there if you want to ask questions. So this is also very good. And the resources I use when I want SQL Server help, these are essential blogs that I use. Blogs from SQL Skills, Paul Randall and Kimberly Tripp, Brent Ozar, Glenn Berry. This is a list of all important SQL Server blocks that you can have by a guy named Thomas LaRocque. His Twitter avatar is SQL Rockstar, I think. And if you want to have help on Twitter, use the SQL help hashtag. Okay. By the way, we also have a SharePoint hashtag, SPHelp, if you want quick help. So key takeaways: know the limits and boundaries, understand about logging and recovery, definitely read the Essentials article that I showed you, plan for disk layout and configuration, enable instant file initialization, use PowerShell, tune your database settings, use aliases, and check for consistency weekly. And that is all. Thank you.